Hello everyone. So in this lecture we'll be trying to solve this particular question which is from the chapter that is pure substances, right? Okay, so let us try to solve it. So before solving any question we should read it clearly and understand the question, and we'll be trying to find out what are the given data and what it is asking to find out, right? Okay, so let us read it clearly and let us try to understand. Okay, so let me use the pen. Okay, so yellow. Okay, correct. Okay, so here it is given in certain situation. So let me decrease the thickness. Okay, okay, so in certain situation when only superheated steam is available, a need for saturated steam may arise for any specific purpose, right? So that means we are having with any superheated steam, okay, but we are requiring the saturated steam, right? Okay, so this can be done in a desuperheater shown in the figure, right? So basically it will be requiring the saturated steam, so this can be done inside a desuperheater, right? Okay, so this is a figure which is given to us. So this is nothing but this is a desuperheater. That means the superheated steam is going into this particular device and the saturated steam will be going out from this particular device. Done. Okay, so in which the case water is spread onto the superheated steam in such amounts that the steam leaving the desuperheater is dry and saturated, right? So how we are that is we are getting the saturated steam. What we are doing, we are taking entry, or we are supplying the superheated steam into this particular device whose name is desuperheater, and we are spraying some water, right? So some water is sprayed in this into this particular device, and such that we are getting the dry saturated steam at the exit. Okay, so some data are given to this particular condition. Okay, so what are the given data? Let us see. So before getting the data, let us try to understand. Okay, so okay, so we are having three entry point and exit point, right? That means three interactions, mass interactions is happening at three sections, right? So this is the section 1, that is the state point 1 over here, and this is the state point 2. That means our superheated steam is entering through this particular section, okay, and the saturated steam which is going out from this particular section, right? And at section 3 our steam is entering, sorry, the liquid water which is entering, that is sprayed into the system, right? Okay, so three interactions are there. So some data may be gained for these three conditions, right? Okay, let us see. So what we can assume, the condition that is of the steady condition, steady flow situation, right? So we can apply this particular SFEE, that is the steady flow energy equation, which we learned in the first law of thermodynamics when it is being applied to any open system, right? So from that we know this particular steady flow energy equation, that is m dot h1 plus v1 square by 2 plus gz1 plus q dot, that will be equal to m dot again, that is h2 plus b2 square by 2 plus gz2 plus w dot. Okay, so this is the steady flow energy equation already we have derived. So in this case we will be neglecting the kinetic energy change and potential energy change, right? And there is no heat interaction we can assume, so this will be also neglected, and this there is no work interaction, right? So we will be we can consider only the enthalpy is the energy of the system, energy which is going to the system along the fluid or along the steam or along the liquid water, right? So only enthalpy will be considering, all other form of energy will be neglected. Okay, so this equation keep in mind, and we are going to apply this particular equation in this problem. Okay, so let us see the conditions what are given to us. So here it is saying that superheated steam at the rate of this one at this Pascal and this temperature enters the D superheater, right? Okay, so superheated steam is entering. So what is the mass flow rate? That is this much, right? So we can write the given data where m dot 1 which is given to us as 0.25 kg per second, right? And pressure is given to us, that is P1, it is equal to 3 megapascal, right? So this can be written as 30 bar, right? Okay, and temperature is given to us as, that is T1, this is given to us as 350 degree Celsius. Okay, so these are the given data for state point 1, right? Data, sorry. So for step point 1 these are the given data. Okay, let us read further. The dry saturated vapor lives at this much megapascal pressure, right? So we can write for step point 2 what is given, P2, right? So P2 it is given 2.5 megapascal, right? So this can be written as 25 bar. Okay, so this is given. Other than this, some data are also given related to this state point 3, right? Okay, so the spray water enters at 35 degrees centigrade and this pressure, right? So we can write P3 is given, there is 3.2 megapascal, and so this can be written as 32 bar, right? And temperature is, that is T3, it is given to us as 35 degrees centigrade. Okay, so these are the data which are given to us. Okay, so what it is asking to find out? So it is asking to find out, we have to calculate the mass flow rate of spray water, right? So if I am saying this m.1 amount of mass is entering in the form of superheated steam, and I am saying m.2 amount of saturated steam is going out of this particular device, then it is asking how much amount of mass will be entering to the D superheater in the form of m3 dot, right? So we have to find out this value. Okay, so hope the question is clear. You have understood what is given and what we want to find out, right? Okay, so what we are going to do, we are going to use the steady flow energy equation. So steady flow energy equation will be consisting of two conservations, right? We know the mass conservation. That means, so if this is any device, the amount of mass is entering to this particular system, that amount is also going out of the system, right? Okay, so here I can see this is m dot, this will be also m dot, right? So this is the conservation of mass, right? So in our case, so this is our D superheater. Okay, so this is state point 1 and m dot 1 is entering to the system, m dot 2 is going out of the system, and m dot 3 it is entering to the system, right? So it will be applying the conservation of mass, that is entering mass, okay, and the exit mass, they will be equal. So I can write according to conservation of mass, I can write m dot 1 plus m dot 3, that will be equal to m dot 2, right? Let this is equation number 1. Done. Okay, now we have another conservation, that is the conservation of energy, conservation of energy, right? So this is the steady flow energy equation, right? So already I have told you that we are going to neglect the kinetic energy change and potential energy change, right? So you will be doing that, the energy which is coming into the system, that will be equal to energy which is going out of the system, right? So here I can write, so there is some energy which is coming into the system with the this superheated steam, right? Some energy is coming to the system with this spray water, and some energy which is going out of the system by this particular saturated state. Okay, so I can write here that m dot 1 h1 plus m dot 3 h3, that will be equal to m dot 2 h2, right? So this is equation number 2, right? So now we are having how many equations? Obviously two equations, right? So one equation we got from the conservation of mass, another equation we got from the conservation of energy, right? So there are two equations, right? So let us check in these two equations what are the given data for us. Okay, so here this is given, right? So m1 is given, okay, and we are asked to find out the value of m3 dot, right? And we do not know the value of m2. Okay, so in this equation again m1 is known and m3 we want to find out, and this is not given. Okay, so if we can find out the value of h1, h3 and h2, in this case, in this particular equations there will be two unknowns. Who are they? This is m3 dot and m2 dot. Similarly, already there are two unknowns, right? So if there are two unknowns and we will be having two equations, then easily by solving we can find out the solution of this particular equations, right? So let us now try to find out the values of this enthalpy. So now we'll be trying to find out the value of h1 and then h2, then h3. Okay, so after finding out these three values, we will be putting all these values over these two equations, and by solving these two equations we can calculate the values of m3 dot. Okay, so now let us try to find out. Okay, so for calculating the value of this h1, okay, we have to consider the data which are corresponding to the state point 1. Okay, so corresponding to state point 1, what are the data given to us? It is given that superheated steam, right? Superheated steam is entering and the pressure temperature is given, right? Okay, so we have to go to the superheated steam table, and corresponding to this 30 bar and 350 degrees centigrade, we have to check the values of enthalpy. Okay, so now let us go to the superheated steam table. So here is a stream table with me. So this is by the RS Kurmi. Okay, so let us check. So directly we have to go to the superheated properties of water, right? Okay, so here you can see we are having the, this is the saturated property according to the pressure. Similarly we'll be having the saturated property according to the temperature. So this is the saturated water stream table, water and steam property tables, right? And this is the saturated water where pressure is given, right? So basically we will be trying to use this superheated steam, right? Okay, so let us try to check, and we want to find out the enthalpy, right? Specific enthalpy of the superheated steam. So this is page number 18 to 20. Let us move to page number 18 to 20. Directly I'm going to the superheated property. So these are the saturated water property, right? Let us move and check. Okay, so here you can see this is the quad, specific enthalpy of superheated steam, right? Okay, so what was our condition? Our condition was that pressure was how much? That is 30 bar. Okay, so here it is starting from 0.02. Okay, so let us check the 30 bar pressure. Okay, so here it is 30 bar pressure. Okay, and 30 bar pressure we have to find out the data corresponding to the temperature value, that is 350, right? So 30 bar here and 350 here, right? So let us check the enthalpy. So here we'll be getting this one, right? So this is 3117.5, right? Obviously kilojoule per kg. Okay, so here you can see that this will be the answer for your H1, right? So so did you get how did we find this particular value? So I'm going to this 30 bar pressure, and corresponding to 30 bar pressure now I'm checking for 350 degrees centigrade. Okay, so here I'm getting this particular value, that is 3117.5. Okay, so let us return back to our. So here we can say H1 value we got how much, that is 3117.5. okay, so this data we got from the steam table. So I can write from steam table, right? From superheated steam table or steam properties, we got H1 equal to 3117.5 kilojoule per kg, right? Okay, so we got one data, that is H1. Okay, so now let us try to find out the value of H2, right? For that let us check the property conditions for point 2, right? So at point, what is the condition? This is the saturated state, isn't it? So this is saturated state. So at point 2 we are having with the saturated steam, and pressure is what? 25 bar. Okay, so we have to find out the enthalpy or specific enthalpy of the saturated steam corresponding to this 25 bar pressure. Okay, so now let us move to steam table again. So in this steam table we can see, okay, so now we have to move to your saturated properties, right? And what is given? We are given with this pressure value, that is 25 bar. Okay, so saturated property and pressure, that is 25 bar. Okay, let us move. Okay, so this is the temperature table, right? If temperature would be given, then we would be using this particular table, right? So we are given with the pressure value, so we'll be moving to the pressure table, right? Here, so you can see here pressure is given in terms of bar, right? So we have to go to the 25 bar, isn't it? Okay, let me check. Yeah, so this is 25 bar. Okay, so here it is starting from the 0.0061. Okay, so why it is starting from the 0.0061? Because it is the triple point of water, right? So triple point pressure is this one, 0.0061 bar. Okay, okay, so let us move and find out our pressure value, that is 25. Okay, so this is 25, here I'm getting, so this is 25. Okay, and corresponding to this 25 bar we have to check the specific enthalpy of what? Specific enthalpy of the gas or vapor, saturated vapor, right? So here this column is for the specific enthalpy of the saturated liquid, and here this is the column which is giving us the values of specific enthalpy corresponding to the saturated vapor. Okay, so from this column and from this row, so I can get this value, that is 2801.0, right? So this will be the value of for your specific enthalpy for the saturated steam. Okay, so here I got the value of our H2, that is 2801 kilojoule per kg. Okay, so just return back to the board. So here I can write now from saturated property, from saturated properties at 25 bar H2, which is equal to Hg at 25 bar, that will be equal to 2801.0 kilojoule per kg. Okay, so let us check it again. Is it right? 2801, right? Correct. So again we got another answer, that is H2. Done. Okay, so now we have to find out the value of H3. Okay, so let us try to find out that. Okay, so now how we will be finding? Let us check the properties of the point 2. Okay, so let us check that. So here you can see at point 3 we are supplying what? We are supplying the saturated liquid. Okay, so we are supplying liquid water. The pressure is 32 bar and temperature is 35 degrees centigrade. Okay, so let us check. So let us check this data from the saturated steam first. Okay, saturated table, right? So we may go to this 32 bar or 35 degrees centigrade, so we can get some idea, right? So let us check. I am going to 32 bar. So if I'll be going to 32 bar, here you can see, so the saturation temperature is this one, right? So this is 237.4 degrees centigrade, right? So at this particular temperature, our liquid will be converting into the vapor, right? But temperature is what right now? This is 35 degrees centigrade, right? So 35 degrees centigrade. So that means now we are supplying the we are not supplying the saturated liquid, but we can say we are supplying the compressed liquid. Okay, that means if I'll be trying to draw in any property diagram, so what will be the condition of our what that is let me what did it so this is the property diagram which I have drawn over here. So this is temperature versus entropy, and this is the constant pressure corresponding to 32 bar. Okay, so corresponding to 32 bar, this will be the saturation temperature. Okay, so this saturation temperature we can get from the steam table, that is what, this 237.4, right? So here I can say this temperature is 237.4 obviously degree centigrade, right? But now our temperature of this liquid, it is very less than this particular temperature, right? And this is somewhere here, so let this is 35 degrees centigrade, right? So this is not the saturated liquid which is entering to the desuperator. So at this particular condition, our steam or the liquid water is entering. That means this is the compressed liquid, right? Okay, so in this case, if I want to find out the value of what so in this condition, if I want to find out the value of enthalpy at this particular point, then how can we find out that? Okay, so let us try to find out this. Okay, so in this condition, actually what is happening, we are having at this particular condition where pressure is this one and temperature is this one. Okay, so this is the inlet point. Okay, and the final is what? At the final condition, our your what is the your superheated steam, sorry, saturated steam, it is going out, right? So at the state point 2, your superheated saturated steam, at state point 2 your saturated steam is going out of this particular device, right? So this is the final condition. Okay, entry condition is what? Entry condition is 35 degrees centigrade temperature and pressure is this one. Okay, and final condition is what? The temperature, obviously this is the saturation temperature. Okay, so this is the saturation temperature because we the saturated steam is going out of this particular device, and the pressure, obviously here the pressure of this particular steam, so the steam pressure will be equal to the spray pressure, right? So initial condition is this one, final condition will be the condition of this one. Okay, so initially it will be having some amount of enthalpy, so this is corresponding to this particular point, right? So whatever enthalpy was there at this particular point, so that enthalpy we want to find out, right? That means at this particular point, so I hope you can see still, let me use another clear color. Okay, so at this particular point, how much enthalpy we want to find out, right? So what is the final pressure right now? So pressure is decreasing, isn't it? So because the initial pressure was 32, right? So here it was 32, now final pressure is 25 bar, right? So 25 bar and saturation temperature, right? So corresponding to that, we have to find out to the value of enthalpy, right? So let us check. So this is 32 bar. Now suppose this is corresponding to your 25 bar, right? So this is corresponding to 25 bar, right? So now from here to here I'm going, here to here. So how much amount of energy we are increasing? that I can calculate because I can find the temperature difference, right? So here you can see it seems that the temperature is equal, right? So this will be not be equal, your pressure at this particular point will be somewhat lower to this one, right? So this is the point, and I'm going from this particular point to this particular point, right? So let me show from here to here. So this, so is it becoming complicated? Let me redraw it. Okay, so this may be the this particular point, this is step point 3, and I'm going from here to here, right? So this is the saturated region, saturated liquid, and this is the point to which our liquid is entering to the D superheater, right? So here to here I'm going, right? So this enthalpy, this is H3, plus I'm adding some amount of enthalpy, this one, right? So I can say this is as DH, that will be equal to the enthalpy which is over here, right? And this is the enthalpy I can write, this is HF, because this is the enthalpy which is equal to the specific enthalpy of the saturated liquid at 25 bar. Is it clear? Okay, so I'm saying initially the enthalpy was this one, or the point was this one, right? So now I added some enthalpy to it, right? So after adding the enthalpy, now I reached at this particular point, that is saturated point, right? Obviously exit point will be this one, isn't it? So this is the exit point. So at this exit point, the temperature is equal to this point, right? So I can find out from this one, right? Okay, so here S3 was the point, then I added DH. So now this is the HFL, right? So S3 we want to find out. So now if I know these two values, then I can find out the value of S3, right? Okay, so HF, how can you find out that? So HF will be equal to what? This is HF, okay, at 25 bar. Okay, so how can I find out that? At 25 bar, the HFL. Okay, so let us check. Let us go to the steam table again. Okay, so at 25 bar, the HF value. So this is the HF, right? So this is the HF value. So that is 961.9. So let me write it that is HF is equal to this. HF is equal to, how much is it? This is 961.9. This is 961.9 kilojoule per kg. Okay, now this DH, how can we find out that? So this DH equal to what? This DH equal to Cp into dt. Okay, so if I'm saying this is the step point A and this is step point B, then I can write this is equal to what? Cp T minus Ta. Okay, so Ta we know already. What is this value? This is equal to 35 degrees centigrade. Okay, now we do not know the value of Tb. Okay, so how to find out the value? Already I have told you that this is the saturation temperature corresponding to this 25 bar pressure, right? Okay, so let us go to the steam table again, and already we know this is the saturation temperature, that is 223.9. okay, so I can write Tb is equal to 2 to, how much is it? 223.9. so this is 223.9 degrees centigrade. Okay, so this is Tb, this one, and this is Ta, this is, okay, and Cp for water we know this is equal to 4.18 kilojoule per kg Kelvin. Okay, now if we'll be trying to find out the value of dH, that also we can calculate. So dH will be equal to what? 4.18 into 223.9 minus 35. Okay, so if we'll be calculating this value, then we can find out the answer. Let me calculate. So this is 4.18 into, this is 223.9 minus 35. Okay, so you will be getting the answer DS value, that is 789.6 kilojoule per kg, right? So DS value you calculated, and HF value you found out from the steam table. Okay, so now you can find out the value of H3. Okay, so let us put all these values. So what is that? H3 will be equal to HF minus DH. Okay, so HF equal to what? 961.9 minus this is 789.6. so here you will be getting 961.9 minus 789.6. so here you will be getting this is 172.3 kilojoule per kg, right? So H3 you got, this is 172.3 kilojoule per kg. Okay, so this is what you got for the value of H3, right? Okay, so already you found out all these values, that is h1 and h2 and h3. Okay, so let me write the equations again. So we are given with, this is m dot 1 plus m dot 3, that will be equal to m2 dot, right? Another equation was there, so this was the equation number 1, right? And equation number 2 was that m dot 1 h1 plus m dot 3 h3, that is equal to m dot 2 h2. So this is equation number 2, right? So now we have to put all these values. Okay, so m dot 1, how much was it given? This is 0.25, I think, right? So let me check. Okay, so m dot 1, which is given to us as 0.25 kg per second, right? Okay, so let us put the values. I can write here as 0.25 plus m dot 3 will be equal to m dot 2. Okay, similarly here I can write 0.25, and how much we found out the value of h1, that is 3117, I think, right? So h1 is 3117 and h2 is this is 2801. h1 is 3117.5, right? So this is 3117, this is 3117.5. okay, this is m3 dot, we have to find out. s3 we calculated, this is 172.3, that is equal to m2 dot into s3, that is m2 dot into s3, right? So h2, right? h2 already we find out, that is 2801. Okay, so now you can rearrange this particular equation and try to solve. So here m3 dot we have to find out, right? So this equation and this equation will be solving, and directly you can solve by using calculator. Okay, so to calculate, let me write down the equation. So I can write m3 dot minus m2 dot plus 0.25 is equal to 0. Let this is equation number A, and here I can write again m3 dot. So how much? It is 172.3 m3 dot minus m2 dot, right? So I can write this one, this is 2801 m2 dot plus this is 0.25 into 3117.5, so this is equal to 779.375, that is equal to 0. So this is equation number A and this is equation number B. Okay, so now you have to solve these two equations. So directly you can use the scientific calculator, and by using the scientific calculator you can find out the value of this one and this one, right? So you can find out the value of m3 dot and m2 dot, right? So we are asked to find out the value of only m3 dot. Okay, so use the calculator. So let me use the calculator also. So after calculation you can find out the value of m3 as 0.03 kg per second, and you can find out the value of m2 dot, that is as 0.28 kg per second, right? So these two values you can directly find out from the calculation. Okay, you can use the calculator, scientific calculator. By using the scientific calculator you can find out these two values, right? So let us check the equations which if it is satisfying the conservation of mass or not, because m dot 1 which was given to us as 0.25, right, kg per second, right? So m1 is this one, and if I'll be adding 0.03 with 0. This is 25, obviously we'll be getting 0.28. So this is only to check if we got the correct answer or not. So this will be the answer for your question, that is m dot 3, that will equal to 0.03 kg per second. Okay, so hope it was understandable. Now I think you can solve the question. Okay, so let me show the solution in a page. So hope you understand this question, right? So we started discussing by considering the data which were given to us. So simply we applied this conservation of mass over here, then conservation of energy. So m dot 1 given, we want to find out the value of m3, right? So if we can find out the value of h1, h2 and s3, that is h1, s3 and h2, then we can find out the value of m3, right? So h1, how can we find out? This is the superheated steam. For the superheated steam, we can find out from the superheated steam table. So for superheated steam table, the 25 bar is given, sorry, 30 bar is given, and corresponding to 30 bar and 350 degree centigrade, we can find out the value of H1, right? Again, for H2, saturated steam property at 25 bar, so corresponding to 25 bar Hg value, that will be H2, right? So these are easy one, but it will be little complicated to find out the value of S3, right? So how can we find out the value of S3? So S3 will be the energy at the inlet of the liquid, right? That is the compressed liquid, right? So at this particular compressed liquid, we are adding some amount of energy so that we are getting the saturated steam, right? So saturated steam, that means the outlet pressure will be equal to the pressure of the saturated steam, okay, and the temperature will be obviously saturated steam temperature, right? So temperature we can find out corresponding to 25 bar, whatever the saturation temperature, that will be the saturation that will be the temperature of the steam which is going out, right? So TB value we can find out from the steam table, that is the saturated steam table at 25 bar, right? So that is we found out as what, this is 223.9 degrees centigrade, right? And from that we can calculate how much amount of heat is required to go from the 35 degrees centigrade to 223.9 degrees centigrade, right? So that is CPDT, and from that we can find out the value of pH, right? And the HF value at 25 bar, that we can find out from the steam table, that is 961.9 kJ per kg, right? So after calculating the value of DS and HF, we can find out the value of S3, right? So after calculating the values of H1 and H2 and S3, simply we have to put all these values over in this particular equations which were already there in this previous case, right? So after putting all these values over here, then simply we have to use the scientific calculator and find out the value of M3 dot. Okay, so hope it is clear. So try to solve many more questions, and all the best. Thank you.